Alright, in the last video we took this generator out of storage and did some minor repairs to it and got it running after it had been sitting for several years. I've taken the generator outside. Now that I know it runs, we'll be doing some additional testing on it out here. I went ahead and replaced the radiator hose with a flex hose and filled it up with water. I have not started the generator since I pulled it out of the shop. It is fairly cool this morning. It's just a couple degrees above freezing, so we'll get a chance to actually start this thing when it's really cold out. And we'll go ahead and run through some tests and see if we can uncover any additional problems with it. Alright, I'm going to go ahead and start this generator up, and we'll go ahead and run the RPMs up and down and take a look at the gauges. And I'm just looking for any abnormalities, anything I wouldn't expect to see from a normal running generator. Alright, the generator actually started quite well for the temperature that it is outside, but I wasn't able to adjust the engine's RPMs up above 50 hertz. It's usually not a good sign because that usually indicates an injection pump problem. They can be rebuilt, but it is a few $100s, and it definitely takes away from my bottom line on this. So I'll go ahead and take a look at things and see if we can figure out why the engine RPM won't change. Alright, after a little bit of troubleshooting, I've determined that the injection pump is probably actually okay. The engine has a pretty good bark to it when you start it up, which means the injector pressure is probably pretty good. I think what's actually going on is the linkage to the injection pump is actually seized up just a little bit, probably from sitting for too long. So even though the throttle cable still moves, the actual linkage is on a spring, and I've sprayed it with some penetrating oil. I'm going to go ahead and try and start the generator up and work the throttle open and closed, and we'll see if we can't get injection pump control lever to get a full range of motion. Alright, as you could hear, I was actually able to rev the engine up and down, and the engine actually sounds pretty healthy. I'd say the injection pump's in pretty good shape. So all I really needed to do is add some penetrating oil to the control surfaces, and just from sitting for so long they were gummed up a little bit and didn't want to move when I moved the throttle cable. So I was able to adjust it up to 60 hertz and all the way down to the low scale on the frequency meter down to about 45. So it sounds like we have a good engine. What I'm going to do now is start it up and let it run for a few minutes. And I'm going to take just a walk around and look for anything out of the ordinary. I'll be looking for water leaks, oil leaks, checking the head gasket, see if I have any seepage coming out of there. Same thing with the valve cover gasket. I'll also be watching the fuel lines, fuel filters and oil filter, check and make sure I don't have any leaks coming out of those canisters or any of the external lines. I'll also be watching just for anything unusual. Any kind of sparks, noises, smoke, strange smells, anything like that. I'm also going to be checking the gauges, make sure that the thermostat opens when it does come up to temperature. I'll also be looking at the ammeter for the batteries, making sure that it starts off at a high rate of charge and dies back down to zero within 30 seconds or so. Make sure the voltage regulator is working properly on the alternator. Once all that's done, I'll go ahead and shut it down, and I'm going to be checking the oil level, make sure I'm not introducing diesel fuel into the crankcase. I'll also be checking the water level in the radiator, make sure I'm not losing water anywhere. And if all those things check out, we'll go ahead and hook it up to the load bank and put a load on it. We'll start testing the overloads and then actually put the generator to work. This extra load will test out a lot of things. It'll test out the cooling system, it'll test out the condition of the engine itself, and specifically the injection pump, injectors, and just the overall health of the engine. Okay, I've uncovered a little bit of a problem here with the generator set to 60 Hertz. When you start it up, and when you're holding the start switch in the start position, the generator is flashing the generator field to start producing power. And during that time, it's bumping the voltage up to about 250 volts, and that's tripping the over voltage safety on the generator. So as soon as you release the start switch, then the engine shuts back down. It doesn't seem to be doing it for when I have the generator adjusted to a lower RPM. So it's probably just an adjustment set point. I'll go ahead and look through the tech manual and see what's necessary to make that adjustment, adjust that set point so that we're not getting that spurious trip. Alright, I'm going to demonstrate the problem we're experiencing here with the over voltage on the startup. Now you can see the voltmeter on the left right here. We're set up for 208 volts, 3-phase right now. So during normal operation, that's what the voltmeter actually reads, but when we're starting it up and it's flashing the field, we're getting about 250 volts or so, and that's tripping the generator on over voltage. So you'll see when I start it up the voltmeter spike, and you'll see the over voltage light, and then you'll hear the engine shut back down. This actually is pretty normal behavior to see the voltage spike like that on the startup. The field flash generates that high voltage spike. So I believe it's just a set point issue. We'll go ahead and demonstrate what's going on here, and then I'll open up the tech manual and we'll figure out how to get it adjusted. As you can see right there, the generator started right up with no problem and came up to almost 260 volts that time. And as soon as I released the start switch, the over voltage light came on and the generator shut itself back down. So the safety is actually working the way it should. I think we're just need to make some adjustments on the set point. Okay, I'm going to head on into the shop and spend a few minutes reading through the technical manuals and see what information I can dig up on the over voltage protection device. While I'm in there, I'm going to go ahead and start the generator up and let it run so I can do the leak checks that I described earlier. I can bypass the overvolt protective device by placing the battle short switch in battle short. Having it there should ignore the over voltage trip. So we'll go ahead and fire it up and let it run for a few minutes, and I'll hopefully come back with some information on that protective device. Alright, I've had the engine running for probably 15 to 20 minutes now, and I went ahead and checked all the gauges. Everything looked normal. The thermostat definitely opened, and temperature was in the normal operating range. I didn't see anything abnormal on any of the gauges. Even the voltage was proper, right at 208 volts and about 120 volts for each individual line. I went ahead and walked around the generator and took a look at everything inside, and I don't see anything out of the ordinary. Everything appears to be tight. There's no leaks, nothing showing up for any of the cooling system, fuel system, oil, and everything. I went ahead and checked the oil level, and it doesn't appear to be contaminated by anything. It's nice and clean. There's no evidence of any water. The level hasn't risen at all, so I'm fairly certain it's not pumping any diesel into the oil system. And everything seems to be running pretty good, so hopefully we'll get this over voltage problem sorted out, and then we can continue with the testing. Okay, I've spent a few minutes reading the technical manual, and I've determined that the overvoltage trip set point is 153 volts plus or minus 3 volts. Now, what I've done is hooked up my voltmeter across the output of the generator, and what I'm going to do is start up the generator and verify that the output agrees with the generator's built-in voltmeter. Now, what may be going on is that the voltmeter is reading too low of a voltage, and I may just have the output set too high, and the overvoltage trip may be functioning just the way it's supposed to. I'm also going to verify the frequency meters, and I'll be doing this check across all 3 lines on the output of the generator. So let's go ahead and get the test started. Alright, as you can see in the video, the voltmeter agreed almost exactly with the generator's meter, but the frequency meter was way off. The generator I had set to exactly 60 hertz on its built-in frequency meter, and as you can see on the digital frequency meter, we were almost at 66 hertz. So that's more than likely why the overvoltage trip is occurring. The generator is simply turning way too fast. So what I need to do is just adjust the frequency meter, and we can get the generator turning at the proper RPM. And I'm betting that that'll take care of our overvoltage trip on the startup. Alright, the way that these frequency meters work on these MEP generators is that they use what's called a frequency transducer, and that provides a DC output that's proportional to the frequency input. Now, I've seen a few that are adjustable, so if they're off like this one is, you can actually adjust the bias on them and bring the frequency meter back into range. And I've also seen other ones that are a matched set, and you have to replace the frequency meter and the transducer at the same time. So we'll take this frequency transducer off and see if it's an adjustable one, or if we're going to have to replace both the meter and the frequency transducer. I went through my bin of spare parts, and I managed to come up with a frequency transducer that'll work in this generator. It's an adjustable type, so I was able to install it in here and bring it into adjustment to match the existing meter that's in here. I set it up so it indicates the proper frequency all the way from 45 up to 65 hertz. So I verified that against my digital voltmeter. So now that we have that adjusted properly, I set the generator for 60 hertz and started it several times, and I didn't have a single overvoltage trip. So that was definitely the problem. Running the generator at such a high RPM was causing the overvoltage trip on the startup. So now that we're running it at the proper RPM, we don't have that problem anymore. This is the old frequency transducer right here. This is a non-adjustable type. You can see I have some kind of black tarry substance that's leaking out of it. So this is definitely our culprit. It's just maybe exposed to moisture, or just possibly reached its end of life. So we'll go ahead and throw it in the trash and continue on with our generator testing. Alright, during the last several runs I've been going around the generator and just taking a look at things each time I shut it down, just continuing to check for leaks and any other obvious problems. And I noticed it hasn't started to drift yet, but I do notice a little bit of an oil sheen showing up right here. This is where I installed the oil pressure switch in the last video, and it looks like I probably just didn't get it tight enough. I did add thread sealant to it, but I didn't tighten it down with the wrench because I didn't want to mess up the threads or risk breaking the pressure switch. So I'll go ahead and get a wrench on it and tighten it down a little bit more, clean it up, and see if we've stopped that little leak. Alright, now that we have our frequency meter repaired and we've taken care of the overvoltage trip problem, I went ahead and hooked up the load bank to the generator. Now what I'm going to do is just apply a few varying loads to the generator, and I'm going to just be checking for proper response. I'm going to be watching the meters, make sure that they're indicating the proper current and the proper overall power. And then what I'll do is I'll test the overload trips on the individual phases. So we'll hit it with some fairly large loads and make sure that the generator protective devices work as they're expected. Alright, everything seems to be operating properly. As you saw in the video, the generator was able to handle a fairly significant overload without too much droop. I didn't get any spurious trips or anything like that. I went ahead and walked around the generator while it was running under an overload like that. I didn't notice any components that appeared to be getting hot or any melted insulation or anything like that. So now that we've gone ahead and placed this generator under a load, I'm going to go ahead and test the overload trips on the individual phases. Okay, after several minutes of testing, I've been able to test the overloads on each of the 3 phases. All 3 were just fine. I set the load at about 140% of rated current on each phase, and each one tripped within a few minutes. Okay, during this stage of testing, the generator has accrued a little over an hour of runtime on it. It's gone from a full cold condition to warm up and cooled back down again several times. It's given me the opportunity to check for fluid leaks in the coolant, fuel, and oil systems. And other than the small oil leak that showed up near the oil pressure switch, I haven't had any other fluid leaks. So this generator looks like it's going to be a good running unit. What I'm going to go ahead and do now is drain and flush the coolant system and get some antifreeze in there so I don't have to worry about it freezing overnight. And then we'll go ahead and hook up the load bank and do a full load test on it.